So hi, I'm Mateus, and we are going to talk about the paper named Towards Modeling Semi-Automatic Ontology Based on Natural Language Process. This study was conducted by me, Mateus Carvalho, Vitor Hayashi, Felipe Pinna, Rosangela Marquesone, João Neto, and Wilson Ruggiero. We are all researchers from the Laboratory of Computer Architecture and Networks from the Polytechnic School from the University of São Paulo. So here are the summary of the presentation. We are going to talk about some concepts in the introduction. We will talk about the more traditional knowledge development process, the manual process, and we will show our proposed semi-automatic scheme for this process. Then we will talk about some results, related work, and final considerations. So here we have some concepts that is relevant for this study. The first topic is knowledge engineer, and we can understand this as a process whose the objective is to formally represent how a specialist would act and take decision. And going deeper in this subject, we will get in touch with ontology engineer. Because if you want to work with domain-specific concept representation, knowledge representation, this is one of the most popular knowledge engineer technique, being highly recommended for evolutive process. It is important to highlight that we have two main specialists in this process. We have the domain specialist, the specialist in area that the solution will work, and the knowledge engineer, the specialist in knowledge representation. The domain specialist must validate the representation created by the knowledge engineer. So, as we can infer, the manual process is slow and laborious, and here we try to improve this process. We developed some use case in a specific business domain, banking service, and with some tasks in Brazilian Portuguese description. So we can define the objective of this study as the optimization of the specialist and knowledge engineer time by automating laborious steps in the ontology development process. We think that the use case for provided a relevant improvement in the process, and we think that the result is very relevant. So here is the manual process. We can understand this process as the combination of two methodologies, the methodology 101 and the methodology AMOD, agile methodology for ontology development. And the combination of these two methodologies uh, results in the following steps. First, the definition of specific domain scope. Then we analyze the existing ontologies and enumerate main terms. After that, we will go to sequence of iterative actions. We will define class, instance, and hierarchy. We will define term properties and define necessary data and relation. After this loop, we can define the rules and restrictions, and then an evaluation can be done. So if the result is considered acceptable, we can go to the post-game phase where action as ontology, integration, and complete documentation are done. So we can think that the last slide is our reference, and now we will show the proposed semi-automatic scheme. So we have the text in Brazilian Portuguese, a natural language specification that will be parsed by the syntactic analyzer. With syntactic analysis and some rules, this model will transform this text in RDF candidate triples. These candidate triples will be passed by the word similarity. This model will calculate the similarity between the object and subject of each triple. Then human intervention is necessary. So here the specialist must select and adjust some triples, and here it's also important to set if each triple is hierarchical or not, because this will show to our ontology constructor model whether a element is a class, subclass, instance, relation, or property. So these selected triple are parsed by the ontology constructor model, and we will get the initial ontology. Then we can go to the last steps to get the final ontology. That is the fine-tuning validation steps. So this is our proposed semi-automatic scheme, and now Vitor will talk about some results related work and final remarks. Thank you.
Thank you, Mateus. So starting with the results, I will present 3 use cases of our semi-automatic approach. All 3 ontologies will be described in our use cases were developed by us, the authors, using our semi-automatic scheme. And this first one describes a task ontology, and the following 2 use cases describe domain ontologies. So for this first use case, I will use a Brazilian Portuguese text, and its free translation to English is the following one. The solution will describe the account opening process. In the account opening, the desired bank account is informed, and some documents must be provided. These account types may be checking account, savings account, and salary account, and also international account. The necessary documents are RG, CPF, residence proof, and income proof. So we can observe that we have some hierarchical relationships and non-hierarchical relationships regarding, for example, the types of the account that are possible to open, and non-hierarchical relationships like this one, like the necessary documents that you must provide in order to open an account. So just to illustrate how our syntactic analyzer works, we have this figure. So RDF triples from the form subject, predicate, and object are identified in each phrase by the syntactic analysis. And we use the space Python library. So for the phrases whose duration is the phrase root, for example, the word necessário in the first phrase of this figure, the phrase subject is the RDF triples object, the word CPF in the first phrase, and the phrase object is the RDF triples subject, where you deposit this figure. Whenever the relation is not the phrase root, the phrase subject is the RDF triples subject. So we have a correspondence between some elements that we found in the syntactic analysis and the RDF triple components. And we translate this. And by doing this with our approach, it is possible to obtain more than one RDF triple from each phrase. Further, something that was not possible in the literature that we found. So let's go step by step. The first one shows hierarchical relationships. The specialist must select and adjust the triples provided in the spreadsheet. Verbs, subjects, and object names were standardized, and each triple must be classified. So this phrase here, these accounts may be checking account, savings account, salary account, and international account. This provides us some hierarchical relationships, like account types may be checking account, and the same thing goes on for the other types of accounts. And so the specialist must assign these relationships as hierarchical. And in the another step, we have another phrase. In the account opening, desired bank account type is informed and some documents must be provided. The triple is not non-hierarchical, and it is. Account opening must be provided some documents, and the specialist must adjust it to account opening must provide document and assign this as non-hierarchical. So after we constructed the ontologies, we must use them in our system. So this is one example of a Sparkle query that the ontology must support. And in this example, the query aims to obtain all taxes associated with one specific product, that is the CDB, that is a fixed income investment in Brazil. The result obtained with the ontology developed with our approach is IOF and the income tax, two taxes present in Brazilian CDB that it was actually provided the Brazilian Portuguese text. So it is possible to use our semi-automatic approach to integrate two ontologies from two different texts. For example, the first text can describe the Brazilian investments at a top level with the various types of fixed and variable income investments. And the second text can represent one of these investments in detail. For example, the CDB from the Sparkle query example. The semi-automatic approach could reduce the total time needed from 37 hours to 22 hours, a relative reduction of 40% by improving 4 out of the 90 steps in total. Terms hierarchy, properties, and relations definition were steps that could be automated. So we actually built in the 30 use case using the manual process and our semi-automatic approach. And the comparison shows that the task ontology constructed with the semi-automatic approach resembles the manual approach ontology. Actually, there are some differences, but as there is no unique way to develop a domain according to one premise of methodology 101 present in the literature, the information in the modeling is not wrong. Still, a given configuration using, for example, the manual approach or the semi-automatic approach may be more interesting than the other, depending on the application needed. So about the related work, most approaches do not support non-hierarchical relationships, or Brazilian Portuguese, or, for example, are not specialized in the banking domain, like we use it in our user cases. So for example, we have the Sarah in 2013. That is a solution customized to the health domain that supports Brazilian Portuguese, but only identifies taxonomic relationships. And the last related work, Liu from 2018, presents an end-to-end application for deriving triples, RDF triples from natural language text, but it could only identify one relationship by trace. So about the final considerations, our proposed solution is a semi-automatic ontology development approach based on natural language descriptions in Brazilian Portuguese to optimize the laborious manual process of ontology development. We present a study case about the banking use cases, and the comparison of manual process indicated the proposed methods capability to optimize specialists and knowledge engineers times effort, according to our objective. The comparison of related work presents the proposal's novelty regarding the support for both non-hierarchical and hierarchical relationships, specialization for Brazilian Portuguese, and the banking domain. And our approach also further extends literature triples identification with Brazilian Portuguese, with a syntactic analysis to identify more than one RDF triple in each phrase. For future work, it is possible to improve the specialists and knowledge engineers' refinement and validation steps. And another research opportunity is to extend our tool to support a bottom-up approach so that a large banking ontology could be constructed incrementally, if you reduce the specialist efforts. The authors take the support provided by Foundation of Support at the University of São Paulo and the Laboratory of Computer Architecture and Networks. These are the references that we use it. Thank you very much. This was the paper towards modeling semi-automatic ontology based on natural language processing. Thank you.